Hello guys, hope you're doing well. My name is Mahmoud Kiasari and welcome to the new chapter of Electrical Circuit. At this chapter, as I promised, right now do have enough knowledge about inductors, capacitors, and resistors, and we would like to solve a couple of questions together in order to make sure that we completely understand it. Because this is going to be the final section of this circuit. I guess we do have enough knowledge about everything so we can solve everything, and it is important to validate our work. Without further ado, let's talk about it. So as I just told you, at this chapter, I would like to solve a couple of questions related to RLC circuits. So as you can see over here, we do have our first part or our first sector, which is mostly about the reviewing. It means that if you guys remember, we do have the tau, which means that the time constants related to this inductor itself is R times C. What was the time constant? The amount of time that it takes for a capacitor to reach to its 63.2% of voltage, because capacitor is getting charged and it's getting its energy getting stored inside the electrical field. At the same time, we do have the T or the tau related to inductor, which is going to be L over R. As you guys remember, the energy is going to be stored inside the magnetic field of inductor. But the W, the amount of energy, is half of CV2 for the capacitor. For inductor is half of Li2. So for the capacitor, while that capacitor is going to imagine that for the first question, I do have my voltage source. It is connected to 47 kilo ohm and 10 microfarad. So the question is simple. The very first part is to find the tau. As you guys know, tau is equals R times C. So what do I have? I do have 47K times 10 microfarad. The micro is going to 10 to the power negative 6, while the kilo is going to be 10 to the power positive 3. So by multiplying these two, I do have 470 milliseconds, as you can see over here, in order to reach to 63.2% of maximum voltage. What is the maximum voltage? Maximum voltage is the time that your capacitor is getting fully charged. When your capacitor is getting fully charged, this guy is going to be open circuit. No current goes past through your resistor, and all of the voltage is going to be connected to your source voltage. So for the capacitor, we do have the 20 volt as the maximum voltage. So what is the amount of voltage that your capacitor would have after maybe 1 tau? At this point, is going, the only thing you need to do is just times 63.2% by 12.64. Or you can use the formula itself, because as you guys know, the charging formula for a capacitor is Vt, or the timing, is equals to V saturated times 1 e to the power negative t over tau itself. Or you can do that, doesn't matter. On another hand, we do have the inductor, while it's getting connected to the same scenario but different some kind of numbers. So we do have the 50 volt as a voltage source, we do have 100 ohm, we do have 250 millihenry. The tau is equals L divided by R. So your L is 250 millihenry, or 0.25 divided by R is 100, so you have 2.5 milliseconds. The starting point, you don't have any currents, because we know inductor doesn't like the changes, especially at the beginning, but after some point, or after 5 tau, you're going to have your maximum current, which is going to be V divided by R. Simple as that. Let's go for the second question, or some kind of the second section. This is talking about the discharging. So imagine that you do have a condition that your capacitor is fully charged and you do have the 48 volt. Then you would connect it to a 12K. We would like to see how much does it take for my capacitor to get fully discharged. So the tau again is R times C, 1.2 seconds. So the time to drop to 6 volts, it means that some kind of, you guys remember, we do have for the voltage of capacitor while it's discharging is going to be V0 times e to the power negative t over tau itself. So the question is simple. Time to drop to 6 volt. It means that my voltage on that time is 6. So my V0 is going to be 48. And if I would like to find my e to the power negative t over tau, I have to divide 6 by 48 itself. On another hand, the real question is that how I can find the t itself. An important part is that you have to consider that your voltage is going to be negative, because it's flipped. At this point, we had the charging like this one, but this charging would be like this. So, in another hand, t over tau can be considered as what? As ln, let me just put it over here, ln of 6 over 48, or your t equals the tau ln of 6 over 48. So if you find this calculation, you can see that at 2.5 seconds, you do have the 6 volt itself. And energy dissipated is half of CV2, so you can find it simple. On the other hand, we do have the inductor. So inductor, imagine at this point, I do have what? I do have my 500 millihenry, and this guy is carrying 2 amp at this maximum. I do have the 50 ohm, and I would like to see what would happen to current. Again, remember that the direction of current would be flipped while it's discharging. The tau is going to be L over R, and an initial some kind of kick or amount of initial some kind of voltage can be considered as that, because as you know, the amount of current at the beginning is so high, or its maximum. 2 times 50 is 100 volts. It means that at the beginning, your inductor has 100 volts, and polarity would be reverse. And if you would like to find some kind of amount of energy, is half of Li squared, so we can simply find it. So what would happen if I do have the combination, or if I do have the series RLC, the combination of all of them? I do have my inductor, I do have my capacitor, I do have my resistor, and I do have 24 volts. So at this point, we would like to see what would happen at t is equals to infinite. Your inductor is going to act as a wire, so zero voltage drop, but your capacitor is going to act as an open circuit, so no current would pass through that. At this point, if I would like to find the current, I is 0, obviously no kind of way or no kind of path I do have in order to reach to a closed loop, so I don't have any current. The V of resistor is 0, the V of inductor is 0, and V of capacitor is 24 volt. Why? Because on that point, this guy is just a wire. The I is equals to 0, so this guy is going to act as a wire, and your capacitor is fully connected to your voltage source, and all of the voltage is going to be dissipated or be considered for your capacitor itself. On another hand, we do have the path of least resistance. What does that mean? Imagine that you do have the power resistor with what? We do have the R and L. Why? We do have another R, and we do have the 36 volts. So what would happen after the infinite time? It means that while your inductor is getting fully charged, while your inductor getting fully charged, this guy is going to be act as the normal wire. So you have R is 6 ohm, R is 12 ohm, and you do have 36 volts. So simply you can find the amount of current goes this way and so finding the current in the second branch means that you can find the saturated current for your inductor, right? So the saturated current would be what? Would going to be 6 amp. On another hand, imagine that we do have the same scenario, but this time instead of inductor, we do have a capacitor. So what would happen to capacitor after some time? Your capacitor getting charged, and this point is going to be open circuit. Doesn't matter what resistance you have on the side, everything is gone. So if you would like to find the amount of currents that go through your middle branch or resistive branch, is going to be 60 divided by 20, and you do have what? You do have a 3 amp, while you don't have any current for your capacitor itself. So let's consider the series parallel condition, the inductive path. Imagine that I do have the 48 volts as an input of DC, I do have 8 ohm, then I do have 24 ohm, I do have the inductor while it's in parallel with 12 ohm. By the way, another important thing that I would like to mention, that I believe you guys already know, is that try to answer the question by yourself by pausing the video, then come back again and try to compare your answer with mine, try to completely understand and master everything. So what do I have right now? I would like to find what would happen after 5 tau or after infinite. So obviously after infinity, your inductor is gone, or your inductor is just a short circuit. While inductor is short circuit, and if you put it, or if you make it in parallel with your resistance, what do you have? You have a wire, while the current is not going to go pass through those resistors, because the wire would like the least amount of resistor in the middle in order to pass, right? So what do you have? You do have 24 ohms, you do have the 8 ohms, and you do have the 48 volts. By having those and considering that, so you just have this simply of 2 resistors in series, and you do have your voltage source. So the current, or the total current, is going to be 48 divided by 16, and finally you have your current itself, which is going to be 3 amp. So if you would like to consider how much current that goes through your, we do have the 3 amp itself. Actually, its branch current doesn't make any sense right now because all of the current goes path through your some kind of inductor and there's no branching there. So forget about it. Then we do have the series and parallel of capacitor. Imagine that we do have the same condition, but we do have the capacitor on the side. It means that I do have 25, I do have 50, I do have a capacitor in parallel with it. So what would happen to current? Obviously, after 5 tau, your capacitor is getting fully charged, so no current go through that one. All of the current go through this 50 guy and this 25. So your final current would be the combination of voltage and resistor itself. Their total resistance is 25 plus 50, 75 ohm, and the I total would be 100 divided by 75. You have as 1.33. if you would like to find the amount of voltage that your capacitor is going to sense at the end, you have to find the voltage of resistor itself. Obviously, those things are in parallel, so that completely makes sense. So voltage of your capacitor is going to be the voltage of resistor, 50 multiplied by 133, so you have 66.7 volts. Simple as that. So what would happen if you do have the complicated scenario? Imagine that you have a 72 volt, you do have a 6 ohm, you do have resistors like this, and capacitor, you have inductor, and you do have another resistor. At the beginning of the point, it seems so complicated, but when you remember about the rule of infinity and beyond, so your capacitor is just acting as an open circuit while your inductor acts as a short circuit. So what would happen at this time? You do have your 18 and 12, which are in parallel. This guy is gone, so they are going to be in series with 4, and all of them is going to be in series with your R1, which is 6 ohm. So you simply can find the amount of current itself, right? So you can find the total current that you do have it over here as going to be 2.67. At the same time, I need to find the amount of current that goes this way. So that completely makes sense. If I assume that that is 2.67, because this capacitor is gone, this guy is gone, so all of the currents would go this way. It's going to be as the same as the total current, 2.67. But what would happen if I would like to find the voltage of the capacitor? Simply just multiply the 4 ohms by 2.67, and you do have your voltage itself, which is going to be, what, 48 volt. That completely makes sense. So let's go for another question, the instance of change, because as you know, at t is equals to 0, your inductor doesn't like any changes and doesn't like any current to go path. So your I is equals to 0. So at I is equals to 0, or at t is equals to 0, actually, I is 0, no current goes path through that, so obviously your capacitor is not going to sense any current. But at the same time, since this is an open circuit, this guy is gone, so all of the voltage that your capacitor would sense is going to be 40. And that completely makes sense, because we know at the beginning of the point, capacitor has the maximum amount of voltage while your inductor is gone. So let's see about the energy seesaw, and imagine that we do have the RLC oscillations. At the same point, I do have my some kind of amount of electric field that is stored inside my capacitor is 2.5 joule, and I would like to see that how much amount of inductor I should have if I would like to dissipate this amount of energy inside the inductor itself. So simply, you can say that half of CV2, which is the amount of energy inside your capacitor, should be half of Li2, which is the amount of energy inside the inductor. By solving those guys, and by considering the fact, we need to see at what is maximum current that actually is happening between these two. By making these guys at the same, or making them the same, you can find the I maximum is going to be 5 amp itself, which is not that kind of important thing, but an important question would be next slide as we are going to talk about it. Another thing is about the timeline. I mean, it's charging and discharging. It is not very some kind of quantified question. It is just about the charging and discharging of the inductor that you have to remember this guy or this some kind of diagram should be like this, while the discharging diagram should be like that. I mean, simply find the numbers or put numbers while you're making the charging and discharging. By the way, the current itself, for some of you that maybe forgot about that, the IT or of the inductor itself would be V, if you do have this some kind of normal R, V divided by R equivalent times 1 subtracted by e to the power negative over tau. So this is about the charging. And at the same time, about the itself would be I0, or amount of maximum current, e to the power negative t over tau itself. So tau would be R over L, and you can simplify whatever you need. This question is so important because it has a very, very important in itself, the resonance frequency. So what is the resonant frequency? Resonant frequency is the time that your capacitor and inductor do have the same amount of inductance, and they can simply cancel out each other. What is the inductance? Inductance is a concept that you would face it while you're working with AC circuits, because at DC circuits doesn't make sense. X of C is 1 over 2 pi FC. This is the inductance for your capacitor, and X of L is 2 pi FL. It means that at what frequency I can say that inductor and capacitor can cancel out each other, because X of C and X of L, they do have the same concept, while X of C or the inductance of capacitor is negative, while the X of L or the amount of inductance for your inductor is positive. At one point, these two guys can be equal. So if you put these equations equal and make it the same, so you do have a formula that F is equals 1 over 2 pi times root of LC. This is something we call as a resonant frequency. The resonant frequency is very important, especially when we are talking about the filtering. You would talk about it in the more advanced or electrical circuit 2, and don't worry about it. But this is something that I would like to know at the end of this chapter. So as you guys just saw, we talked about different kind of concepts in this electrical circuit course. It was around 30 chapters. I tried to put so many questions for you in order to completely make sure you guys understand it. And again, don't forget to put any comment for me. If you do have any question, I would be more than happy to answer that for you. Please subscribe, like, and share. That would be so for me. My name is Mahmoud Kiasari. Have a great day, night, whatever. See you around with the next chapter, which is going to be electrical circuit 2.